So today we're going to be discussing the concept of multiplying a matrix by a matrix. And we'll be using the row by column product. And so to illustrate this, let's consider the following situation. Say you live in Dallas, Texas, right? You live in Dallas. And you are being sent by your company to New York City, NYC. Maybe this is a school field trip. On the other hand, maybe you're being sent by your school to New York City. Either way, you have your start point and you have an end point. And let's say you have 3 possible airports that you can go to. We'll call them A1, A2, and A3. And depending on their distance from you, you can get to these airports in slightly different ways. So A1, your first airport, is the furthest away from you. So at best, you can probably only drive there, right? And there's only one way to arrive. As for your second airport, it's a little bit closer. You can bike there and also drive there. So there are 2 ways to arrive at this given airport. And lastly, A3, your third airport, maybe it's in your backyard. It's literally just a stone's throw away. Probably not the case in real life, but in either way, there are a total of 3 ways. You can bike, you can walk, and you can drive. Now for the second leg of your journey, going from the airport to New York City in this case, let's say your first airport has a certain number of flights leaving from it on the day that you want to go. So airport 1 perhaps has 3 direct flights from Dallas to New York City, and airport 2 maybe only has 1, and airport 3 has, let's give it 2 direct flights from airport 3 to New York City. And so considering the situation that we have here, the question is, how many ways can we go from Dallas, Texas to New York City? And so, with that in mind, let's just consider how many ways can you arrive at each of these airports and how many ways can you fundamentally leave them, right? So for your first airport, there's 1 way to arrive and 3 ways to leave. And so there's a total of 3 paths that go through airport 1. On the other hand, as for airport 2, there are 2 ways to arrive and 1 way to leave. And so there's 2 paths that go through airport 2. And you have another 3 by 2 paths that go through airport 3, following the same logic. And clearly, this adds up to be 3 plus 2 plus 6, which is 11. So there's a total of 11 possibilities that correspond to the given situation. Now, there has to be another way that we can represent this problem. Let me shrink the diagram that we have here. There's another way that we can represent this problem and use it in such a way such that the data is presented in its most efficient form. So as you may remember, we have covered the concept of basic vector and matrix operations, from adding to scalar multiplication. This is where the idea, instead of multiplying a matrix by a matrix, so it's no longer scalar, comes into play. And so in this case, let's break this journey down into your first and second legs. So the first part of your journey, the first leg of your journey, consists of going from Dallas, Texas to each of these airports. And let's call this leg of your journey M, right? And let's say out of all these, your first choice going from your first airport has 1 way of getting there. To your second airport, it has 2 possible ways of getting there. And if you want to go from Dallas, your home, to the third airport, there's a total of 3 possible ways. And so we'll call this first leg M, just general area. Now for the second leg of your journey, we'll call this N right here. And so N, on the other hand, consists of 3 possible airports, A1, A2, and A3, and these 3 possible airports have a total of 3, 1, and 2 ways of arriving at New York City, of having these flights that you can take. Now notice how we set up these 2 matrices to represent the problem. In this case, and let me draw a more generic kind of matrix here, the number of rows that you have represent the number of possible places you can be leaving from. So in the case of N, you have a total of 3 airports that you can possibly be leaving from, right? You have 3 airports. You can either be at A1, you can be at A2, you can be at A3, but these are 3 different scenarios. And the number of columns, on the other hand, each of these columns represent where you could end up. So in the case of n, taking that same example, there's only one place. Your end goal is New York City, and so it is a one column matrix. Similarly, with M, you can end up at any of these 3 airports, and as a result, there are a total of 3 different columns right here. Alright, so taking the same convention that we have, clearly what this implies is that when we multiply M times N, right? Because that's how you find the number of paths, possible routes that you can take from Dallas to New York City in the given scenario. This is clearly equal to 11. So let me write that out for you. That's like writing 1, 2, 3, and taking this matrix right here and multiplying it by your second matrix, which in turn should be equal to this. Right, and this is basically what we had earlier, and as we established, this is equal to 11, and so this scenario here represents a sort of simplified form of maybe a certain case that you might encounter in real life, a certain situation that fundamentally reflects the idea of multiplying a matrix by a matrix or a vector by a vector. And so going on from there, let's consider a little bit more of a general case for multiplying a matrix by a matrix. Now, if you notice, what we're doing here is, let's say you have a certain matrix. Let's do 3, 1, 2, 4, and note this is a 2-column matrix, by the way, and another 2 and a 5. And let's multiply this by, let's give it 2, 3, 4, 5. Right? And if you notice here, the number of columns in my first matrix, it corresponds to the number of rows in my second matrix. And to make that a little bit clear, a little bit more clear, let me add a couple of items. All right, and so clearly here your number of rows and columns correspond to each other. And if you notice, if I took these two and I flipped their locations, the end result, according to the pattern we established a little bit earlier, will not be the same. And so this essentially corresponds. This might take a little bit of extra space. Essentially, let's calculate the first term here. Corresponds to matching this. So 3 times 2 plus 1 times 4. Right? And taking that first scenario that we had earlier, this is like the routes you can take from Dallas to your first airport. So from Dallas to your first airport, and then maybe from your first airport to New York City. And of course, because we do have more than one row and because we do have more than one column here, clearly there's more than one possible city or airport that we may be attempting to get to. Alright, and so this is your first term right here. And so it goes on from there. If you want to do a second term, going on from there, you can do 2 to 4 as 3 to 5, and it kind of matches itself. And if you notice, if you look very carefully, there's a certain given pattern that we're establishing here. So let's say you have a matrix, you have A, and it's composed of all these terms, lowercase a with location ij, and this is like a coordinate plane. And let's say you have another matrix corresponding and made of terms, again with ij locations, right? And we want to figure out what a times b is, and it corresponds to all these terms, and we'll call them p, ij, and this is the generalized definition, definitely not written very formally, but pij, where p is basically equal to, and following what we said earlier, is equal to a of I1, right? And this is location, so I1, right? And this is your a. Here, let me shrink this matrix a little bit. So this is A, and this is B, right? Your I1 matrix times B, which is your 1J, so 1J, right? Plus AI2, right here, times B, 2J, so that'll be going down the column here, and so on and so forth. And if you notice here, the i's correspond to the same value, and similarly the same thing can be said about j. And so that's basically the idea behind multiplying matrices and vectors. And of course, doing a little bit of practice with it from an abstract sense might help clear up some of this kind of patterns, these patterns that emerge when you go through and attempt to multiply them. But fundamentally, that is the concept behind this multiplication. Again, if you have any questions, please do not hesitate to ask, and just remember, stay curious and keep on learning.